Welcome to a discussion on 0 raised to the power of 0. When studying algebra, we're given exponent rules, as we see here on the right, where one of them is a to the power of 0 equals 1. And in some textbooks, we'll also see that a, the base, can't equal 0. Well, the truth is, in most algebra classes, we don't consider the case where we have 0 raised to the power of 0. But from my experience, in most cases we say that 0 to the power of 0 is undefined. And let me try to explain why. Let's start by considering 0 raised to the power of 0, which we can rewrite as 0 to the power of negative 2 plus 2, since this sum is still 0. We could actually use any opposites that we wanted to. Let's just use this as an example. Now if we apply the product property of exponents seen here, since we have a sum of exponents, we can write this as a product where the bases are the same. So we can write 0 to the power of negative 2 plus 2 as 0 to the power of negative 2 times 0 to the power of positive 2. And now using the property where we have a negative exponent, we can rewrite this product as a quotient because we can rewrite 0 to the power of negative 2 as 1 over 0 to the power of positive 2. So this product can be written as a quotient, and as a quotient, since 0 to the power of 2 is equal to 0, we have division by 0, which we know is undefined. But unfortunately, this is not the only interpretation of 0 to the power of 0. For example, in calculus, 0 to the power of 0 is an indeterminate form, which means it has no defined value but may be capable of being evaluated by an alternative method. For example, when taking limits in calculus, the use of L'Hopital's rule can help evaluate a limit in the form of 0 to the power of 0. Looking at the limit here, notice that if x is equal to 0, this function would be in the form of 0 to the power of 0. But through the use of logarithms and L'Hopital's rule, we can show this limit is equal to 0. However, I do want to point out that just because the limit of a function is equal to 0, that does not mean the function value would be the same at that given value of x. In fact, the function value still could be undefined. And then through further research, I found that sometimes 0 to the power of 0 is defined as being equal to positive 1. And the reason for this is that it can simplify some formulas and eliminate special cases. For example, if we consider the binomial theorem, as we see stated here, when y is equal to 0, well, if y is equal to 0, we would just have x plus 0 to the power of n, which we know must be equal to x to the power of n. But if we strictly apply the binomial theorem, notice that when k is equal to 0 and y is equal to 0, we would have x to the n times 0 to the power of 0, giving us this product here, which we know must equal x to the power of n. So because of special cases like this, where sometimes we will see 0 to the power of 0 being equal to positive 1. Now if you're wondering what happened to all the other terms in the binomial expansion, since y was equal to 0, each successive term would have a factor of 0 raised to a non-zero power, which is equal to 0, eliminating all successive terms. So as you can see, 0 to the power of 0 is not quite as clear as we hope in mathematics, but I do want to end with a quote that I found when defining 0 to the power of 0 equal to 1. This definition is sometimes used to simplify formulas, but it should be kept in mind that this equality is a definition and not a fundamental mathematical truth. I hope you found this discussion helpful.